In this question, a 10-kilogram block lies on a smooth ramp that is inclined at 30 degrees. What force parallel to the ramp would prevent the block from moving? So we're going to use the method of force resolution. The trick about it is that you can resolve a force vector or any other vector in different ways. But our initial understanding of the force revolution is that vertical is along y-axis and horizontal is along x-axis. So I'll show you how to move from this resolution into a familiar one, which is along y-axis and x-axis. So in order to resolve this force, which is the vector in red, and which is 98 Newton, given that the mass is 10 kilograms, one of the components should be parallel to the ramp, because this is what the question asks. We know that the second component should be perpendicular to the first component. Then this is how it's going to look like. So I labeled them H and V for horizontal and vertical. Now I want you to see that the horizontal has got an angle of 60 degrees with the red vector. Why? Because in this triangle, the angle 30 is given, and this is a right angle triangle, then the other angle is going to be 60 degrees. Now, instead of working with the resolution vectors in this position, I'm going to rotate it, just rotate it clockwise, and then you will get into familiar context where this V is this vertical along the y-axis, and this H is this horizontal along the x-axis, and this is the angle, 60 degrees. Now the question becomes so much easier to understand. So we know from the formula of horizontal that to find its magnitude, we need to multiply the magnitude of the given vector, which is 98 newtons, by the cosine of the angle between them. And this is what I did here on the right. So the final answer is going to be 49 newtons. This is the magnitude of the vector H. And since the question is asking us the force which would stop or prevent the block from moving, then of course it has to be directed up the ramp, upwards here, okay?